All right, next talk. I have absolutely no idea if this one is serious. Eran Tromer is going to tell us about the hunting of the SNARK.
Thank you very much. I'm happy this opportunity to tell you about recent results with my esteemed colleagues. So SNARKs are succinct non-interactive arguments of knowledge. These mythical creatures first identified by Keelan and Micali, who demonstrated succinct arguments, and then making them non-interactive, let alone of knowledge, has been a long-sought problem. Many have sought it with thimbles in care. Gentry and Weeks show that actually they do hide in mythical lands, but actually one of the first portrayals of these creatures goes back to Carroll 76, that's 1876, who showed the following. In this model, we have a beaver that is a small computationally bounded creature who likes having people perform expensive computation on his behalf, these big people floating around, and in particular, there's a butcher nearby who likes to prove an NP statement, wants to prove that there exists a witness that some machine running on some instance X accepts. So the butcher walks for a while and says yes, but of course the beaver doesn't trust the butcher, so he wants a proof. The butcher produces a succinct proof. The verifier checks the proof, is convinced that not only does there exist a witness, that is, the NP statement is true, but moreover, the butcher actually knows this witness. And you might wonder, what is this good for? This is the proof of knowledge. Why would you care? So one reason hides in the previous page of your conference program. If you go back to the delegation of computation program, then 3 out of the 4 papers can be easily reproved if you had SNARKs. Modular efficiency. So, okay, that's 75% might look useful, but how do we get there? So we have a plan. We have a map for hunting SNARKs. It goes like this. You look for a SNARK. So that is a very mythical creature. Let's build a somewhat more tame creature. Let's call it extractable collision-resistant hashes. These are collision-resistant hashes where anyone who gives you an element of their image actually knows something that in their domain that explains it. And how would you get this? Well, actually, these are very powerful creatures in the sense that they employ SNARKs and back. So actually, this is a very nice characterization of what is needed for SNARKs, but we still want to get them. And Weeks and Gentry showed us that we have to cross over to the lands of non-falsifiable assumptions. Let's make some knowledge assumptions. So we propose several assumptions that suffice to get these ECRHs. There is the ever popular, at least recently popular, knowledge of exponent assumption. We make yet another variant that implies SNARKs. We propose one inspired by lattice problems and the approximate GCD that you just heard about twice. Turns out that you can phrase a knowledge assumption about that. That suffices for SNARKs. You can do it with LWE, noisy inner products assumptions. I actually wanted to describe one of these and pose this as a nice cryptanalytic challenge, but the esteemed Rump session chairs for life didn't give me enough time, so let me describe another one, the knowledge of ice cream assumption. So here's the problem. The conjecture is as follows. For every polynomial size adversary, there exists a polynomial size extractor such that whenever the adversary produces a cone of ice cream, then the adversary finds a linear combination of the ice cream flavors that explains how this cone of ice cream was produced. Now, if you can prove this, then you get SNARKs, which are very useful, which is why we've been extensively cryptanalyzing this conjecture over the last few days. You may notice that our ePrint version has been recently revised. We encourage you to seek with thimbles and with care further such assumptions and try to break ours. So the method employed I would gladly define while I have it so clear in my head. I had but the slides and you had but the time, but much yet remains to be said. Thank you.